projector, but now like, yeah, a little headset. You can stand in this space and totally feel what it's like to stand in that space. Well, it turns out all these products are complicated products to build and take a lot of people to work together. So just one person standing in VR looking at it is a good start, but you need to be able to collaborate. One of the things we see is things like pharmaceutical factories get built, and it matters how many steps it takes to get from one station to the next is a big deal. And you would measure it in plans and you would know 6 feet is about that. But once you can stand in it as a human scale, you can walk around the space and you can see exactly what it's like to get from one station to the next, and people start to make changes. Things like hospitals is a huge deal. What can you reach? And automotive is huge. The interior designers always try to build an interior to sit in the driver's seat, and what can I reach from here? And you know what the numbers are like, but once you see it at human scale, it changes everything. So we're seeing a lot of changes in automotive design. So now we're building collaborative design tools for multi-users. So a whole design team can stand in the same virtual space, see the same object at full scale. So the way automotive has traditionally done this is they take 3 to 6 months to build a full-scale clay model of a car, right? They have guys with putty knives who are sculptors and artists making these incredibly detailed cars. And you can't tell the difference when you stand in front of one of these things, and they've sanded it and painted it. It looks and feels exactly like a real car, but it's incredibly expensive and slow. And they used to sit there and argue for a year and a half about where does the highlight fall on the curve of this fender, and you couldn't prove it until you built it and lit it, and you could look at it and stand in front of it, and then you'd go, oh, it's wrong. Oh, we go back to the drawing board. Let's do it again. And so now you can all stand in VR. You can move the lighting, you can change the textures and surfaces, you can do it in real time, and it changes the ballgame. So just a quick little clip of what NVIDIA's been doing in this area is really interesting with their holodeck prototype. They're really exploring this concept of having multi-users. So everybody's got an avatar, everybody's positionally correct, everybody's got hands. You can talk to each other. You've got a toolkit where you can pull a model apart. You can change colors. You can do measurements. You can just draw from here to there, and it'll tell you exactly how long that distance is. You can draw notes to each other, so you can say, show this curve. And so what it looks like is a traditional designer view that they would do with a really expensive clay model. They can now do with the team in real time. You can punch through the model and see the internals and all the components, which is something you can't do with clay. You can do cross sections, just wave your hand, and the whole thing explodes, and now you see how all the parts can fit together. So we're working with companies, with automotive designers that are bringing it to manufacturing now. They can have a conversation with manufacturing as they're building the factory, and they can start to mess with exactly how the parts fit together, and they can make design changes earlier before they've spent a bunch of money on tooling. They can also change colors, environments, show it to me in the daytime, show it to me at night. With ray tracing now, they can sit in an interior and say, you put the sun at the right angle, and you can see exactly where the colors change. I've got headlights behind me, and I've got a reflectance off this dashboard. Now I realize I need to angle that dashboard another degree. So with ray tracing, they're really starting to catch a lot of details. They also do remote collaboration. So you can have, some of these people are in Southern California, some of them are in Tokyo, some of them are in Detroit, but they're all standing in the same virtual space, working and looking at the same model. So this is a revolution in how the business works. And so we're starting to build multi-user GPU systems so that you can drive a bunch of people in the same space off of one machine. So instead of having a workstation for every user and a headset for every user, and the expense and the management of that, we can now put up to 10 GPUs in one box, attach a headset to each one, and now you've got a centrally managed multi-user VR rig that can drive typically anywhere from 2 to 10 users in the same space, and you attach a headset to each one. So you create virtual machines across this architecture, and you attach a headset to each GPU, but they're all in the same box, they're on the same backplane, they're running the same software. They can communicate at super high bandwidth, so you can do super high resolution real-time rendering in VR with these kind of rigs, and that gets you a bunch of benefits. That gets you, it's cheaper, it's easier to manage, it's a smaller footprint, it can be portable, so you can put it in a case and bring it in places where you wouldn't normally be able to bring, 8 PCs. You can just bring one rig. You can do it in things like location-based entertainment rigs, where you have a multi-user game you can power off of one machine. You can remotely manage it all. So it becomes a lot more power efficient. And so we're working with a lot of customers doing these kinds of things. One of them is GE, who's building pharmaceutical factories. They do the whole thing in VR before you even build it. Westfield malls, they render the entire mall in VR. You can walk through the whole space, and the trees are blowing in the wind, and the water fountain is bubbling, and there's traffic noise in the restaurant, and it's crazy what you can do. And then you can pull up a flashlight and shine it into the dark areas, so you can do lots of really amazing things in VR that you can't do in the real world. We have a lot of customers using Autodesk Fred, which is the VR engine most of the automotive design world uses, and we're building tools on top of that for specifically for automotive. You can pull off a tire. It's not a gaming machine. It's for professional, high quality VR. So it's got 2.5K resolution per eye, 170-degree field of view, built-in leap motion hand detection, so you don't need controllers. You can just see your hands. You just hold them up, and all of your fingers are there, and they interact properly. It's got automatic IPD detection, so it can sense where your pupils are and automatically drive the lenses in the headset so they center on your pupils. So there's a bunch of stuff that we can do to make VR quality better for professional use, and that's one of them. But to drive that takes a lot of hardware, a lot of horsepower. So that's what we do. We're building high-powered, high-performance machines with a lot of GPUs to be able to make it as photorealistic as possible in VR, so that you can make better and faster product designs and buildings. So that's my story. Thank you for seeing, and now we can give away some prizes.